I know what you guys are thinking today. Oh no, Mrs. Curtin, your hand modeling career, it's over! I know, I cut my finger, so I guess I better stick to teaching math. Too bad. Alright, 9-1 is about distance and midpoint formulas. So how do we find the distance between 2 points? How do we find the midpoint between 2 points? Suppose I have a little graph, okay, and I have these 2 points. The first point is going to be the point 2, 1, right? 2 in the x and then 1 in the y. And then the second point is going to be the point 5, 3. Okay, so it's a little bit farther in the x, farther in the y. Okay, so how do I find the distance between these 2 points? Now, it's kind of a strange number, right? I don't exactly know how I would find the distance. But let's suppose I just drop a line straight down, that dotted green line, and I realize that between 3 and 1 is just 2, and between, the two x coordinates, 2 and 5, is 3, right? That's how far apart the x's and the y's are. I realize that this actually makes a right triangle shape, which means I can use the Pythagorean theorem, if you recall, to figure out what the third side is, right? I have one side is 3, one side is 2. What's the third side? So I'll figure it out by doing 3 squared plus 2 squared is equal to d squared, and therefore d is equal to the square root of 9 plus 4, which is the square root of 13. Now, if I look at, okay, what is now the midpoint between these two, then I see, well, between 2 and 5, it looks like the midpoint is around, let's see, 1, 2, 3.5. 3.5. Okay, so I just use that by using my graph, right? It's about 3.5 over, and then it's kind of like I can see from my graph that right in between the 2 points is just at 2, right? So that's my y-coordinate of my midpoint formula. So what I want to do, though, is I want to generalize this. For any 2 points, what would be the distance and what would be the midpoint between those 2 points? So let's say the points are P1 is x1, y1, and P2 is x2, y2, right? Those would just be a bunch of numbers. The distance between P1 and P2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So that is the distance formula, and the midpoint formula is I add the x-coordinates together, x1 plus x2, and then divide it by 2, and then I add the y-coordinates together and divide it by 2, and that's in, of course, a point form. But just remember that the distance formula just comes from the Pythagorean theorem, right? Because it's like the distance between the x-coordinates and the y-coordinates, and then I square it. And then the midpoint formula you could also derive, right? That's how you would figure out what is halfway between the two x-coordinates, what's halfway between the two y-coordinates, by adding them together and then dividing by 2. So let's suppose I want to find the distance and midpoint between these 2 points. And so what I'm going to do is I'm going to do a shortcut version. I realize that the x-coordinates are 6 apart and the y-coordinates are 8 apart. So then to find the distance, I'm just going to do the square root of 6 squared plus 8 squared, which is 36 plus 64, which is the square root of 100, which is 10. Awesome. Okay. Whew. Now we are going to find the distance using the actual distance formula, formally, right? So we do -6 minus 0 squared plus 0 minus 8 squared, and then we would figure out what that is. -6 minus 0 is -6. If I square that, it's 36. Anyway, I'm going to end up getting the same answer, which is the square root of 100, which is 10. So then I might want to find the midpoint, and so I would just add the two x-coordinates together, divide by 2, so I get -3, and add the two y-coordinates together and divide by 2, and I get 4. Hopefully that all made sense. So now we're going to find the distance and midpoint between two more complicated looking points. We have 2 plus rad 5, and then the other coordinate is 2 minus rad 6, I believe, yeah. Okay, so then the other point looks very similar, with just a slight variation. It's 2 minus rad 5, and then -2 plus rad 6. Okay, you might notice that the x-coordinates are 2 rad 5 apart. And you might notice that the y-coordinates are 4 apart. Or we can use the distance formula. So here we're going to use the distance formula. We're going to do the first, the second x-coordinate minus the first x-coordinate, and the negative will distribute. And then the second y-coordinate minus the first y-coordinate, and the negative distributes. So then we end up getting the 2's canceling in the first terms. We get -2 rad 5. And then the rad 6's cancel in the second one, and I get just the -4 left over. And when I square both of those things, I get 4 times 5, and I get 16. I get 20 plus 16, and 36, which is the square root is 6. Okay, so now I'm going to find the midpoint. That's easier to find. I just add the two x-coordinates together, divide by 2, add the two y-coordinates together, divide by 2. The rad 5s will cancel in the first one, so I get 2 plus 2 over 2, which is just 2. And then the second one, the 2's cancel, so I get rad 6 plus rad 6, which is 2 rad 6 divided by 2, which is rad 6. So suppose now that we have a point and a midpoint, and I want to figure out what the second point was that made that midpoint. So I'm going to plug all this into the midpoint formula, which I have here. So I'm basically going to take -4 plus the x-coordinate of the second point and then divide that by 2. That should be equal to 0. And same thing with the y-coordinates. 3 plus the y-coordinate of the second point divided by 2 should be equal to 0. So if I solve, I multiply by 2 both sides, and then I add 4 to both sides. I get x is equal to 4. And then with the y's, I multiply by 2 both sides, and then I subtract 3, and I get y is equal to -3. So the coordinates for my second point are 4, -3. What I'm going to do now is I'm going to look at 3 coordinates, and these 3 coordinates are going to make a triangle. And I'm going to try to figure out a few things about this triangle. The first thing I'm going to figure out is it isosceles? That is, does it have 2 equal sides? The second thing is it a right triangle, right? Are 2 of the sides at right angles to each other? So to figure out if it's isosceles, I have to actually figure out what the distances are, what the sides are, right? So 4 and -2 are 6 apart, and then -5 and -8 are 3 apart, right? So I can find AB, take the square root of that, and I end up getting the square root of 36 plus 9, which is the square root of 45, which is 3 rad 5. Okay, so BC, now I'm going to find that. -2 and -8 are 6 apart, -8 and 4 are 12 apart. I square both of those things, take the square root. I get the square root of 36 plus 144, which is the square root of 180, which is 6 rad 5 once I take out whatever I can. And then the last side is CA. What is that? Okay, well, it's 4 and 8. How far apart are those? 12 apart, right? And then -5 and 4, which are 9 apart. I square both those things and then take the square root, and I end up with a square root of 225, which is 15. Okay, so it's not isosceles, right? Because none of those sides are equal. They're all different. But is it right? Well, what I can do is I can use the Pythagorean theorem and take 15 as my longest side, and the longest side will be the hypotenuse if it is a right triangle. And I'm going to square the other 2 sides, add them together, and set them equal to the third side squared, right? So AB squared is the square root of 45 squared, which is 45. BC squared is the square root of 180 squared, which is 180. And CA is the square root of 225 squared, which is 225. Wow, I can't breathe. Okay, so then 45 plus 180 is 225, right? So those 2 things are equal, so the Pythagorean theorem was consistent. So this is a right triangle. Now, lastly, we will figure out what the area is. The area is equal to 1/2 base times height, which is going to be 1/2 times AB times BC. Those are the 2 sides that are not the hypotenuse, and therefore they're the base and the height. And when I evaluate what those are, it's going to be 1/2 times 6, which is 3. 3 times 3 is 9. And then rad 5 times rad 5 is 5. So 9 times 5 is 45. And that's my area. I hope that you have a great day, and good luck on your homework.